Hey everyone, welcome to SingularityComputers Client Build 10, Part 4. In the last part of the build log, I filled both of the loops and brought the wiring close to completion. I've now gone through and completed the last of the custom wiring and cable management, and I've also installed the lighting, so the build is now complete. I'm going to start this part of the build log by answering some of the questions from the previous video. I'm then going to give you a good look around the finished product. I'm also going to take you through the entire Aquero 5 Pro configuration, and finally I'm going to go through all of the test results. So I had a lot of people asking me what case this is. If ever you want to know one of the components I'm using in my builds, you just need to go back to the first video in the build log and watch the first few minutes. I always cover every single component I use. Sometimes I change components around later on, in which case I will still cover the components I use in detail. This is the Case Labs Magnum TH10. I'll put a link on the screen to a review I've done on this case, and also to another build log of my personal primary system Singularity Beast 2, which was also into this case. Now, I had a surprising amount of people ask me why the coolant looks like it's a different color in the reservoir compared to in the rest of the loop. And this is just because there's a further distance from one side of the res to the other compared to in the tubing and the water blocks, so the light has further to penetrate and therefore it looks darker. And that only really goes for the blue coolant because it's transparent. The white coolant is opaque, so it looks the same color everywhere. I also had people asking me about the wiring, basically just about heat shrinkless sleeving. Someone asked, where did I hide the heat shrink? And I'm just going to quickly go through the technique I use for heat shrinkless sleeving. I still use heat shrink, and I heat the heat shrink so much that the sleeving melts underneath. It melts onto the wire, so it's incredibly durable, and I cut the sleeving off afterwards. As I've mentioned previously, when I get some time, I plan on dedicating a bunch of videos to custom wiring. I'm going to do a full series of custom wiring guides. I also had people ask me about this multi-GPU water cooling config. Now, I've talked about series and parallel a lot in previous videos. This is a parallel configuration, and a couple of people said it looks like the coolant just goes straight through and out the other side without actually flowing through any of the water blocks. Obviously, that would be a major problem. But take a look at the inlet and outlet to this config. The inlet is on one side, the outlet is on the other side. If they are on the same side, then yes, the flow would just go straight through and out the other side without going through the water blocks, because the fluid takes the path of least resistance. But in this config, a parallel configuration, 1/3 of the flow of the loop flows through each of the water blocks at the same time, and it's 1/3 because there's 3 water blocks, and because the water blocks are all exactly the same with the same resistance. In a serial configuration, basically half of the tubing here would be taken out, so you only have one tube between each of the water blocks. Then the entire flow of the loop would go through each of the water blocks, but one at a time instead of all at the same time. So essentially the difference between the two is flow. You get better flow with a parallel configuration, and depending on the design of the rest of your loop, one configuration can be more beneficial than the other. I'm not going to go into that now, but which configuration you use makes very little difference. It's really minuscule, so it's not that critical, and I much prefer to use a parallel configuration because I prefer the aesthetics, and most importantly, it's really twice as strong because you have twice as many fittings and twice as much tubing between the graphics cards. So that's why you'll see me using parallel configurations most of the time. I also had some people ask me why I didn't sleeve back to the center of the fans, and this is something that comes up a lot. And this comes down to something I've talked about previously in this build log. This is a client build. If it was up to me, I'd go all out in every single one of my builds with my mods. I'd tend to every little detail, but these builds have budgets and time limits, and this is just one of those little details that really doesn't make much difference to the build. You know, it doesn't benefit the build much. I think these wires you know, in this case, they don't stand out that much because the colors you can also see elsewhere in the build. In some builds it really stands out and looks terrible, and in that case I would be covering these wires. And actually sleeving them is not the answer every time. It depends on the design of the fan. Sometimes sleeving back to the center of the fan will make even more of a mess. So there is other ways of covering the wires, and that's something you'll see in a future video. So now for a look at what I've done since the last part of the build log, the completion of the custom wiring, cable management, and the installation of the lighting. Not much has happened around this side of the build. Most of the work I've done around the back of the build and out of sight. But you can see down here a couple of cables that I've added. One goes to the sound card, which is the Asus Sonar D2X. It provides extra power to the sound card. It's actually a floppy power connector, so I had to make up another custom cable for that. You can also see a cable plugged into one of the USB 2 headers on the motherboard, and that's actually for the Aquero 5 Pro. I'm going to talk about that shortly. For the lighting, I ended up only adding a single Bitfinex Alchemy LED strip down the back of the reservoir with the white coolant in it. So it's fairly well hidden here. I'm going to talk a lot more about the lighting shortly. You can also see it has a custom cable which goes through the hole for the 24-pin motherboard power cable. I've also managed the cables for the 3 fans I've installed into the 5.25-inch bays, and you can hardly see the cables thanks to another ModSmart clip. I've talked a lot about the ModSmart clips I use previously, but I've only talked about the small clips I use for managing my custom cables, basically for holding the individual wire strands together. But ModSmart has a full range of cable clips, and this is one of the larger ones for bundling cables together, running 24-pin cables and larger cables like that, and I use these all the time. I've also done a lot of work up behind the Aquero 5 Pro. So I've done a lot of work on the custom wiring and cable management, and there is a lot of cables up here, but nothing considering the functionality of the Aquero 5 Pro. All I'm using it for in this build is fan curves, which is extremely important. And this device is really unmatched, completely unmatched when it comes to managing, monitoring, and controlling a water cooling loop. It can run every single component. Pumps, lighting, fans, you can read off RPMs, temperatures, even the fluid level in your reservoirs. This device is just amazing, and I'm going to show you just a little bit of its functionality coming up. So now looking around the back of the build. Now considering the specifications of this system, that it's an extremely high-end water-cooled build with dual loops and 20 fans, there's really not a lot of cables back here. And that's because I've done custom wiring. Every single cable in this build is custom, and pretty much 90% of the cables have been made from the ground up, from scratch. And most importantly, all of the cables are at custom lengths. So that means that there is no excess wiring to hide, there's nothing to hide at all. It's a massive amount of work, but I think it's a really important part of a build. It massively improves a build. So first of all, how I've divided the power between the two power supplies. From the top AX1200, I'm running the 24-pin, 8-pin EPS, and 4-pin ATX, and I'm also running a single peripheral cable which powers the Aquero 5 Pro, and from the Aquero is obviously running the 16 radiator fans, so that's actually a Molex cable. From the bottom AX1200, I'm running all of the PCIe, so for the graphics cards, and this connector here I've explained in the last part of the build log. That's how both of the power supplies start at the same time. It has 2 wires that come from the 24-pin connector on the top power supply. I'm also running 3 peripheral cables. The top one goes to the Bits Power X station. From the Bits Power X station, I'm running a splitter PCB. From this splitter PCB, I'm running the 4 case fans. So the 3 case fans in the 5.25-inch bays, and another case fan in the hard drive cage. I'm also running both of the pumps, which you can see there, the other 2 Molex connectors, and the lighting. So the lighting is connected up to a 3-pin fan header, and that goes straight out through the hole just there for the 24-pin motherboard power to the LED strip on the other side. Now you can see here that the top two peripheral cables have heat shrink, the bottom one doesn't. That's because some cables you just have to use heat shrink. And depending on the connector you have on the other end, for example this SATA power cable. And in that case, to match up, I use heat shrink on both ends. So the middle one goes to the SATA power that runs the SSD and both of the hard drives, and the lower one goes to the sound card. Now I saw in the comments some people saying that I've used Tygon tubing back here, but I've actually used Primo Chill Advanced. And I've already mentioned the reason I didn't use acrylic tube back here previously in the build log. So the system is up and running, and at this point I've been through all of the testing and validation. Currently for my client builds, I start with an 8-hour leak test and I then move on to 48 hours of stability testing. Then if the client wants an overclock, I do another 48 hours of stability testing. In the last part of the build log, I talked a lot about how I was going to use UV lighting to blend in these two coolants. And the reason that's so important is because one coolant is opaque, the other is transparent. Without lighting, these coolants really don't blend that well, they stick out. And I've ended up using a single Bitfinex Alchemy Blue LED strip to achieve the same thing I wanted to achieve with the UV lighting. Basically, both coolants are UV reactive, both glow blue under a UV light. So I wanted to use that blue glow to blend the two coolants. So I've put the blue lighting in behind the reservoir with the white coolant. The reason I didn't use UV lighting is because I just wasn't happy with the effect. When I install my lighting, it's always one of the last things I do, and this is because it's something I test a lot. And I don't do that with other aspects of the design of my builds. Usually I envision what I'm going to do. I do design my systems as I build them, but I don't go testing components most of the time. I envision what I'm going to do and then I follow through with it, but you can't really do that with lighting. You really need to see it, so you need to leave it until last. And I always test different colors, different brightnesses, different brands of lighting in different places. And that's what I did in this build, and I tested the UV lighting and the effect was just terrible. And that comes down to the quality of UV lighting. Years ago when I used to build systems, I used to use UV cold cathodes and get the most amazing UV effects. The UV lighting was so good it would only reflect off the UV reactive components and the rest of the build would just be dark. So the coolant and tubing would look glow in the dark, and that's how it should be. That's a proper UV effect. It's not something I see much anymore, and it's not something I'm able to achieve with the current quality of UV lighting. Coming up, I'm going to be testing some UV lighting from Promethean Mutations, which I'm really excited about. So you'll see that video coming up. Now, as well as the LED strip, I was also going to use some LEDs in the CPU and memory water blocks. And I actually had them installed and took them out because I didn't really like the way they looked. They didn't suit this build. And it's because of the frosted water blocks. With a frosted water block, when you install LEDs, you don't get much light radiating out of the block, and it's a little bit difficult to explain, but you end up with this bright block of light. Whereas with transparent water blocks, you end up with different facets of light, a lot of light radiating out, and different brightnesses throughout the block, and that would have suited this build a lot more. So I ended up taking them out, and I prefer this subtle lighting anyway. It's really important to have subtle lighting, and this is something I've talked about a lot in previous videos, to have contrast between light and dark. You need to have that contrast. Try to light up the parts of your build that you want to show off, that you think are most important. And also, you shouldn't really be able to see your light sources. I've now installed all of the panels onto the case, the top panel, front panel, and both of the side panels. This is the largest side panel window you can select for this case. It's the XXL window, and it's worked out perfectly because, as you can see, it lines up perfectly with the top of the reservoirs and also with the top of the lower radiator fans, and it shows all of the main part of the build. Now, there's so much customization you can do to a Case Labs case, And when you're selecting your customizations, when you're purchasing the case, you really need to have some of your build design in mind. For example, I knew I was going to be putting two reservoirs side by side next to the motherboard, so I knew I needed the extra side panel window size. For the rear side panel, I went for the ventilated option, and you can see the ventilation lines up with the power supplies. I've now installed dust filters on the power supplies. These are Silverstone magnetic 140mm dust filters, so they'll be easy to remove and clean. Now, as I've talked about many times previously, when it comes to your thermal design, there's two things you need to think about. The main one is you need to maintain positive pressure inside of your case and have dust filtered intakes. So basically you need to have more fans bringing air into the case than out. And you need to work with convection, hot air risers. So my final thermal design, I have the 4 case fans on the front of the build bringing air in. I have the 8 radiator fans at the bottom bringing air in, and the 8 radiator fans at the top exhausting the air. The power supply fans aren't really making a difference to the pressure inside of the case because they're just drawing air straight in through the side panel and out the back. I just wanted to go into a little bit more detail on what I've done at the front of the build here. So in the 5.25 inch bays at the top, I have the Aquero 5 Pro. Then I have an extra accessory for this case, which is designed for installing an extra 360mm radiator. So even with the massive radiator capacity that this case has by default, you can still go for even more accessories for more radiator capacity or just to give you more options. So I've just used this for installing fans onto, but you can easily mount a 360mm radiator onto the back of it. I've also dust filtered these 3 fans. As you can see, I've installed more Silverstone dust filters onto the front of these fans. At the bottom there I have a 5.25 inch bay cover, and you can also get these in a ventilated option. And then on the right hand side in the 3.5 inch bays, you can actually install hard drive cages all the way down this side, and you can install them into the 5.25 inch bays. I only have 1 hard drive cage installed, and I think this is one of the reasons people get confused about what case this is, and also, you know, with all the Case Labs cases, because every time I do a Case Labs build, I have so many people asking me what case it is. You know, once these panels are removed, it looks like a completely different case, but it's also because of all of the different customizations. Every time you see one of these cases, it's configured completely differently. Okay, now for a look at how I've configured the Aquero 5 Pro and what I'm using it for in this build. I'm doing this by popular demand, and coming up I'm going to dedicate some videos to the Aquero because I get so many questions about it. So I'm now just going to show you one small aspect of its functionality, and that is how to set up fan curves. I'm running 16 radiator fans off the Aquero in this build, and that's it. I'm just using it to manage the fans and to run fan curves for the radiator fans. The Aquero has 4 fan channels. It can handle 1.65 amps per channel, or 5 amps total for the channels put together. This is actually expandable to 10 channels with the Power Adjust, which is an add-on for the Aquero. There's so many add-ons and accessories you can get for it, and the Power Adjust also massively increases the power output. So with 4 channels and 16 fans, obviously I need to split up the fans. The Noiseblocker PL2s I'm running only use 0.16 of an amp, so considering each channel can handle 1.65 amps, it means I can run over 30 Noiseblocker PL2s off the Aquero. So what I'm using to split the fans is splitter PCBs, and I highly recommend them. I recommend against using splitter cables because they just make an absolute mess of cables. They add unnecessary cable length. With splitter PCBs, you can put them right next to your fans, and that's exactly what I've done here. I have one splitter PCB next to each of my radiators. You run the fans directly into the splitter PCBs, and then you only need to run one cable from each splitter PCB back to the Aquero 5 Pro. And you can see where they're connected here to the 4 fan channels, which are underneath the heatsink on the back of the Aquero. Now the brand of splitter PCBs I'm using is Mod My Toys, and I use them because they're high quality, they have a big range, but there is a lot of different options out there. Another important cable you need to have connected to your Aquero is the USB cable. It connects at the top of the Aquero, and you need to run this back to a USB 2 header on your motherboard. And that's how you can access the Aquero's functionality from within your operating system. And that's exactly what we're going to do now. So that's the hardware side of things. Now moving on to the software. Okay, I'm now in the Aquero software. Now there's a lot of detail I'd like to go into here that I'm going to have to leave for future videos. I'm going to try to keep this as short as possible. The first thing you need to do is go and download the latest software. I'll put a link in the video description. The only problems I've had with this device is when the software and or firmware is not up to date. So that's extremely important. Once you've installed the latest software, come down here to Aquero 5, click on that, click on System, Firmware Update / Factory Defaults, and then click Update Firmware Now. The biggest problems I've had is when the software and firmware is not matched. Basically, with every software update, there's a firmware update included. So once you've done that, it takes about 60 seconds to update the firmware, it reboots the device. Come up here to Controller. If you take a look through this software, you can really see how powerful this device is and what it's capable of. It's just amazing. But the only functionality we're going to be taking a look at here today is under the controller. So this is basically the fan controller. And what you'll be faced with when everything is defaulted is a constant value, which you can see here. So all of the fans will be running at 100%. Just ignore that. Go straight up to outputs, and you can see the different controller types here. So there's so much detail here. There's so much that you can do. We're going to select curve controller. So you can see another curve controller has come up here. Now on the left hand side is the data source. So this is where you select the temperature that you're actually going to base the curve on. On the right hand side is what you're going to control. So here you need to select the fan channel so you want to control with this curve. You can actually have one curve per fan channel. So say if you have dual loops like in this system, you might want to have one fan curve per loop. So keep that in mind. With this system, channel 1 and 2 is for the CPU and motherboard. Channel 3 and 4 is for the graphics cards. So you can split them up. The individual fans do not show up here if you've split the fans on the channels. Only the channels show up. So you can configure that how you want to. And then on this side, you need to select the temperature to base the curve on and to base the RPM of those fans that you've selected on. Now, you can see I have quite a lot of temperatures here. And by default, you will only have the temperatures that are actually plugged in to the back of the Aquero 5. There's 8 temperature sensors on the Aquero 5, so you can plug in coolant temp sensors, whatever you want there, and you can base the curves on those. Or if you install another app, there's a few apps that are actually capable of this. The one I'm using is AIDA64, and if you have a water-cooled system, you should be using AIDA64 anyway. I'll put a link in the video description to where you can download it from. What you need to do is share AIDA64's temperatures with AquaSuite. So once it's installed, right-click, open it, click File, Preferences, and come down to External Applications. Tick the top 3 boxes, and then come down to Temperatures. Basically, this is where you select what data you want to share with other applications, in this case AquaSuite. So I've selected all of the temperatures there. You then click OK and come back to the data source, and you'll be able to see a lot more temperatures here. So you can see here I have CPU 1 and GPU 1, and those are the temps I'm actually going to be using to base my 2 fan curves on for the 2 loops in this system. So let's select CPU core 1. Now if you have multiple graphics cards, just select GPU 1 because that's usually the one that gets the hottest, and the temps stay fairly close anyway. I mean, as long as they're within 10 degrees, it's fine. Now now you can configure the actual fan curve itself, and this is very straightforward. You can see here we have power, so it's actually not based on RPM, although you can change that to RPM by coming down here to fans and advanced settings, but you're better off leaving it at power. I just find it works better. You can select the start temperature here, and so that's where the fans start. And you can make them start at 0% power or whatever percentage you want, and then go right up to 100% at whatever temperature you want. You can select a linear curve or progressive curve or somewhere in between. You can drag these to wherever you want to. It's just amazing. So that's it. That's how you set up fan curves with the Aquero 5 Pro. Now moving on to the test results. I'm going to start with the power consumption results. The maximum power consumption I saw out of this build was 987 watts, and that was when the system was overclocked, but it wasn't the most massive overclock. I'd say if this system was heavily overclocked, it could pull 1200 watts. Now moving on to the noise output results. Now the best way I have of giving you a rough idea of the noise output is by giving you a listen to the build through my camera's microphone. I know it's extremely inaccurate though. I'd say the noise output is around 25 decibels, which is a little bit louder than my builds usually are, and it's just because there's 2 pumps and a massive amount of fans. Now that slight clicking you can hear is actually coming from one of the pumps. Remember that some of these components are from the client's previous build, including these pumps. I've never had problems with noise from Langdie 5 pumps. That's what these are. They're the Alpha Cool rebadge. Mainly once they have Bits Power mod kits and mod tops on them. But one of these pumps is slightly loud. That's being very picky here. Now moving on to the temperature results. For all of my temperature testing, I mathematically adjust my ambient temperature to 20 degrees Celsius, and all of these results are in degrees Celsius. I do an idle test and a load test. For the idle test, I cold boot the system and then let it idle for 30 minutes and take my result. For the load test, I run Prime 95 small FFT for 30 minutes and then take my result. For CPUs and multiple graphics cards, my results are an average of the cores. Now the client requested an overclock, so I have stock clock results and overclocked results. I'm going to start with the CPU results. So at stock clocks for the idle test, 21 degrees. Overclock for the idle test, 25 degrees, so 4 degrees hotter. Then for the load tests, 38 degrees at stock clocks and 55 degrees overclocked. Now I didn't end up overclocking the graphics cards. So the stock clock results for the idle, 20 degrees, load 38 degrees. Now I didn't see the motherboard go over 29 degrees Celsius, so that was the maximum recorded temperature during all of my testing, and the same for the PCH at 27 degrees. Now moving on to the performance results. I'm going to show them in screenshots comparing the stock clock results to the overclocked results. So that's it for the results, and that actually concludes this build log. As always, I've really enjoyed building this system. Coming up, I have a lot of systems I'm excited about. I have a lot of systems lined up at the moment. In the next couple of weeks, I'm going to be going back to work on the PAX build log and also the Client Build 9 build log. Thanks for watching. Please subscribe, like and favorite if you want to see more.